Hey everybody, I just wanted to give you this resource for doing your roller coaster calculations just in case you forgot how to do them or you didn't understand when I explained it the first time. So starting on your data sheet, you should have collected that last class and you should have an initial height, a final height, and a bunch of different times for going 1 meter at the end. That was the goal of your data collection. Now your initial height should have stayed the same the whole way, as well as your final height, but your time to go 1 meter should have changed a little bit because you were timing 10 different times, and I'm sure you couldn't be 100% consistent. So after you got all of those times, you should have found final velocities by doing the number of meters you went at the end. For most people it was 1, but if you were going too fast, sometimes you had to do 2. You're going to do that number, so I'm going to use 1, but yours could have been 2, divided by the time for that particular trial, and that answer is going to give you the final velocity. You have to do that 10 times, so you get 10 final velocities over there on your data. And now we're going to take this data and we're going to analyze it on the next few pages. So I'm going to show you how to do that. On the next page that says roller coaster data analysis, you're going to be using this equation, which came from this one. It's just expanded out. And you're going to solve it for thermal energy final, which is exactly what the instructions say. It says for each trial above, find the thermal energy lost to friction, which is the thermal energy final, using the conservation equation, which is written here. So you're going to be pulling givens from each trial. So for example, for each trial, you should have the same height initial. I'm making up numbers, say it was 1.5 meters. And then you're going to have to do a height final. For most people, that was 0 because they decided to measure from wherever they landed. You're going to have a velocity initial of 0 because you were just dropping your marble down the coaster. And you're going to have a velocity final of some number that you measured on the previous thing. So those are your calculations for final velocity. That's going to go here. Say mine was 3-ish meters per second. We'd put that there. And you also know G is 9.8, as always. You're going to plug those into your conservation equation. So we start with kinetic energy initial, right there, 1/2 mvi squared. But my vi is 0, and yours probably is too, so that term goes away, and it is 0. Plus mass times gravity times height. Your mass of the marble is 0.004 kilograms. It's there on your sheet. That's the average mass of the marble. Times gravity, 9.8, times your height initial, which is whatever you measured for your coaster. I'm putting 1.5 because that's my made-up number. Plus thermal energy initial is 0. When you add 0, it doesn't matter, so I'm not even going to write it. And then we get to the final side. You have to do your final kinetic energy, 1/2 times mass, times your final velocity squared, plus mgh, which is probably going to go away to 0 if your height final was 0, but if it's not, you have to include it, plus thermal energy final, which is what you're solving for. So you'll calculate this number over here on the left and this one over here on the right, and you're going to have to subtract those. So I'm just going to write this as left. I'm not using a real number. Equals right plus thermal energy final. To get your thermal final, you're going to have to subtract that right number from both sides to get the answer. You're going to have to do that 10 times, 1 for each trial. The good news is your left side of the equation should always be the same because you had all the same initial conditions for every trial. You had the same kinetic energy of 0, the same thermal energy of 0, and the same initial height, so the same potential energy. So really, all you're going to be changing out every time is this final velocity that you measured. You're going to get different thermal energy numbers 10 times for all your trials. Then at the end of your analysis on page 5, you're going to figure out the average value for thermal energy lost, which means you're going to take all of your answers, all of them, and you're going to add them up. So all answers added, or sum of all trials, and you're going to divide it by the number of trials, which should have been 10. Okay, so add up all your answers, divide it by the number of trials, which was 10. And then to answer question 2, you're going to have to use the answer to question 1. It says, what percentage of your energy was lost? To find the percentage, divide the average from the previous question by your initial potential energy. So you do the average, and that gets divided by your initial potential, which is mass times gravity times height initial, which you should have already calculated 10 times or have carried it through calculations 10 times. It should be in your previous work. You wouldn't have to do it again. But if you need to, it's the 0.004 for the marble times gravity is 9.8 times whatever height initial you were using. And then to turn it into a percentage, I actually forgot to put this on here. You're going to multiply by 100 to make it a percent. So you're going to see if you lost 10% of your energy or 2% of your energy or 80% of your energy. And that's what you're trying to figure out here, how big of an effect that friction has. And then the last thing you need to do is write a conclusion. So your conclusion is already laid out for you. Pretty much it's going to have 4 different parts. One is an introduction, which is what was your setup. That's something about the fact that you built a roller coaster and then you used a marble and this is how you measured your velocity. Just writing about your setup. Then hypothesis number 1, which you should have from your old slides. You're going to state your hypothesis, whether it was right or wrong, and evidence for whether it was right or wrong. You're going to do all 3 of those same things for your second hypothesis. Remember, you should have one hypothesis about your start height versus your loop height, and another one about the role of friction in your experiment. And then the last one is error analysis. So talking about some ways that you tried to keep error out of the experiment and some ways that it could have gotten in. And you need at least 1 sentence per item here, not 4 sentences total. That's 9 sentences total, 1 for each little letter here. A, B, C, all those, they each have to have at least 1 sentence. If it takes you longer than that, go for it. If you need extra notebook paper, you're welcome to use that. That's totally up to you, but you need at least 1 per item here. And this is going to be test grade, the whole packet together, plus your original slides. So make sure you're completing that to the best of your ability and getting that turned in today. I'll see you guys next week.